Hello guys, welcome back to my channel RTL Forge, and I will explain our project is Synchronous FIFO, but this Synchronous FIFO is implement and make a new project is our Abyss Buffer and Sonar Data FIFO controller. Please is explain morely in our Sonar Data FIFO controller. I will explain our problem description and this is a problem description is a deep beneath the ocean and the research the submarine above the pointer of fires sonar pings at the irregular intervals and generating a 8-bit reading that must be the buffer and before the onboard CPU can proceed them. मतलब कि एक ओशियन के अंदर सबमरीन है, उसके अंदर सोनार पिंग्स सोनार सिस्टम है जो 8 बिट डेटा को अपने ऑनबोर्ड सीपीयू के अंदर हर बार स्टोर करवाती रहती है. ठीक है. Your module the implements a synchronous FIFO that accept the sonar reading on a writing data pin when the writing enable pin is assets and make a full signal provided and delivers them in arrival order on reading data pin when the reading enable is assets and provided empty signal. Means ke this is our synchronous FIFO is mostly used and provide two signal full and empty condition, and full is always FIFO data is always write and read, and empty condition is write condition and empty condition is equal to. And I will implement the project and make our third condition is almost full. The almost full condition is the flag must the asset the whenever 6 or more of the 8 slots are occupied and giving the sonar controller time to the throttle a new measurement. मतलब कि ऑलमोस्ट फुल फ्लैग है वो 6 के ऊपर के जो डेटा है 7 6 7 8 ये 3 डेटा आएगा तो वो ऑलमोस्ट फुल फ्लैग को अलाउ कर देगा फीफो को कि फीफो के अंदर ऑलमोस्ट डेटा स्टोर हो चुका है. Please ever all state reset the synchronously when the reset is high on a rising clock edge, and please explain the problem and our translate. I will explain our description and port direction. This is our input pin, clock reset, write enable, write data pin. This is our 8-bit pin, and almost all pin is our 1 bit. Read data and write data pin is our 8 data pin, and clock is provide some process clock. Reset is provide 1 bit reset data, and write enable pin is provided the write enable is equal to 1. FIFO is almost full. This is our main data pin is our write data pin. This is our stored in 8-bit data, and go to the FIFO is full and empty condition. This is our read enable is almost empty condition. Read enable is equal to 1. Go to the condition in empty condition your synchronous FIFO. And this is our output pin, full pin, empty pin, and almost full, and read data. Almost full is always this count this ऑपरेशन पे वर्क करेगा कि 6 या 6 या 6 के ऊपर के डेटा को हमेशा वो पिन को ऑलमोस्ट फुल दे देगा. अगर 8 स्लॉट कंप्लीट हो गया फीफो में तो काउंट इज इक्वल टू 8 इज इक्वल टू फुल कंडीशन इज प्रोवाइडेड, and count is equal to 0 and empty condition provided. And this is our read data actual the oldest sonar reading and hold the last valid value when empty. Basically a simple funda of synchronous FIFO is writing enable p is equal to 1 means full is 1 and FIFO is full. Okay. And read enable pin is equal to 1 means empty condition is 1 and FIFO is empty. Let me some explain our small block diagram in my project. This is our Abyss buffer in sonar system. This is provided in our input pin, clock, reset, write enable, write data pin. This is our 8-bit pin provided 8-bit data in our FIFO input, and this is our read enable pin, and this is our output pin, full, empty, and this is our added in our implement project almost condition, and read data go to the write data and read data is equal to same, and our FIFO is currently correctly run in our synchronous FIFO. Let me some explain our more description in our EDA playground and write the Verilog code in our my project. Let me some explain our Verilog code in our EDA playground. This is simple module, and module name is our project Abyss FIFO, and this is our input pin, our clock, reset, write enable and write data, and read enable, and output pin is our reading the data, and full FT, and implemented condition is our almost full, and these are simple parameter declaration. Depth is equal to 8, and error bits is our 3. 3 binary code is different store the different location in our 8, and this 8 data is provided input in our w writing data, and provide in our FIFO depth, and this is a simple memory array. Provide the memory array is depth 0 to 7 and register in our 0 to 7 because this is our 8-bit memory. This is our simple status register, and all status register is store the data in 8-bit, and shift counter is a 4-bit register, and all register and other register like write WP and RP is our 8-bit register, and this is simple condition in our full empty and almost condition. Full condition provide the counter is our 8, and depth our depth value is 8. Go to the condition in our condition of FIFO is our full, and provided FT condition, and Q is equal to 0, and output is our 0, and the condition is our FT, and provide the FIFO is our FT, and data is input is available. Okay, and almost full is condition. This is Q is equal to 7, and our output is our 6. So 6 is equal to 6. We almost full condition is run, and 6 greater than is equal to other signal like a 7 and 8. So almost full condition is run. This is simple based simple fundamental condition in our almost full condition. This is our simple line if is our writing and reading, and a simple condition our write enable pin is equal to 1, and full condition is 0, and FIFO is our full, and the write enable pin is equal to 1, FIFO is our FT, and provide some data in our FIFO, and this is simple data in our write pointer, read pointer and counter, and read data is our 8 hexadecimal like 8 bit data ही हो गया उसका. This is our simple this is our simple our write pointer, and this is our simple code is our read pointer. Write pointer is the this is a simple circular or increment 0 से लेके 8 तक, and this line provide a circular increment like 0 से लेके 8 तक. Let me some main our coded line is this our counter become a 0, and provide some value is +1. this is our write only condition, because कि काउंट में काउंटर क्यों +1 देगा कि काउंटर में कोई वैल्यू आ रहा है कि 10 20 30, तो डेटा को स्टोर करेगा, 10 डेटा को स्टोर करेगा तो उसमें से एक माइनस हो गया, तो ये रीड कंडीशन हो जाएगी कि रीड कंडीशन में 10 को रीड कर दिया, और फिर +1 राइट कंडीशन मीन्स फिर अगली बार जो डेटा आएगा वो आएगा 20 30 और 40. These two major line discuss the all code is our run based of the V. This is our end of the case and end module, and this is our end of the Verilog code, and this is a simple Verilog code in our run this problem project, and I will explain our test bench code. I will our test bench code. Let's some explain our simple condition in our this is our simple 6 condition and 6 scenario provided in our best EPU waveform provided in our project our Abyss Buffer and Sonar Data FIFO controller. This is our first scenario is our write when full, right enable pin is equal to high and go to the full condition, and FIFO is our full condition. This is our read and read enable pin is high and read data is our hold the value is our last valid value, मतलब कि इसके अंदर लास्ट का जो डेटा है वो स्टोर रहेगा और FIFO अपना नया डेटा स्टोर नहीं करने देगा. दिस अवर सिंपल सिनेरियो ऑफ अवर सेकंड. दिस अवर थर्ड सिनेरियो. This our third scenario is a simulation read plus write and when fuel. This all two condition is our this combine a third scenario. Write enable pin and read enable pin is always high. Go to the third scenario and provide the condition is full. And other opposite side, the read and write condition is our 0 and provide some empty condition. This is our simple condition. This is our reset mid operation. Reset assessed by the both write enable pin is equal to 1, reset is equal to 1 and read enable is equal to 1. All three pin is high. The all pointers and counter must clear to 0. मतलब कि FIFO यहाँ पे अपना सारा डेटा रिमूव कर देगा. ऑल पॉइंटर्स एयर काउंट इज इक्वल टू क्लियर. एंड लास्ट सिनेरियो इज अवर ऑलमोस्ट फुल बाउंड्री इज अवर काउंटर इज इक्वल टू 5. ऑलमोस्ट फुल मस्ट बी द लो एंड काउंटर 6 इज इक्वल टू इट मस्ट बी द हाई. मतलब कि 6 के ऊपर का कोई भी डेटा जाएगा तो वो उसको ऑलमोस्ट फुल करके वो सिग्नल कंडीशन बता देगा FIFO को. दिस इज सिंपल कंडीशन एंड all 6 condition is code in our test bench code, and this is our test bench code is a time scale and time is our 1:1 ps. This is our module declaration and name of the test bench of bias FIFO. This is our register store the input value and wire store the our output value, output pin और our input pin को हम यहाँ registered value में wire में store कर रहे हैं. This is our duct declaration provide some put clock to clock, reset to reset and wire to wire and another vice versa. The initial clock is equal to 0 and always 5 टाइम के बाद ये क्लॉक अपने आप रीसेट हो जाएगी 0 1 and 1 to 0. ओके, दिस अवर सिंपल ईपी वेव जनरेट के लिए ये लाइन लिखी गई है, मतलब कि अपना ईपी वेव 4 डम फाइल में अंदर स्टोर हो जाएगा. इंटीजर इज अवर आई. लेट मी सम एक्सप्लेन अवर टेस्ट 1. टेस्ट 1 इज अवर द हैप्पी पाथ. इज अवर provide the some value is right pointer, right enable pin is 1 and go to the data is input in our FIFO. Let me some explain our first data is our A1, B2 and C3 and go to the read enable pin is our A1 because read enable pin is equal to 0 and provide some data is always 1, मतलब कि A1. This is our simple test. This is our right when. This is our test 2, test 3, test 4, test 5 and test. This is our simple 6 scenario. और अपने previous lesson में मैंने discuss किया. This is a simple code in our test bench code and I will run and explain our EP waveform. And let me some explain our EP waveform is our project, and this is our first scenario is our A1, A2 and C3 and go to the read data is our always A1. This is our first scenario is completed and see the first scenario is a write enable pin our always 1 and go to the data is our A1, B2 and C3. always write enable pin 1 होगा तभी ये डेटा को इनपुट करने देगा और जब ये रीड एनेबल पिन 1 होगा तभी ये डेटा को रीड करेगा. दिस इज फर्स्ट सिनेरियो. दिस इज अवर सेकंड सिनेरियो इज अवर ऑलमोस्ट फुल कंडीशन. दिस इज अवर 0 1 2 3 4 5 and 6. This is our 6 condition and go to the our almost full condition is run and go to the 1 provided. Let me some explain other 8 to 2 bit and go to the 8 our almost FIFO is full. Go to the full condition is run and go to the provide is 1. This is our all complete the complete EP waveform is run in our this project.